Good morning, everyone. We are the final year project group 2 who is building a software tool to design LV installation distribution system for optimal operation. The main objective of our project is to develop a graphical user interface based software tool to optimize the low voltage cable paths and position switchboards to minimize the electrical losses within the electrical distribution system. Our sub-objectives are to obtain an algorithm to design energy-efficient and cost-effective LV distribution systems, develop a software tool for LV distribution system which is user-friendly and time-saving, and the ability to design safe, energy-efficient and economical domestic, commercial and industrial installations. Now let us go through the system model and how it is implemented in our software. Our system consists of a graphical user interface which is used to input the load layout and parameters of the installation and get the cable layout and total cost and the cable sizes as the output. Inside the system, we will be selecting new distribution board positions using the simulated annealing algorithm and will be finding the minimum cable paths using the Hightowers algorithm. Then for each cable path, we will be optimizing the cable size and calculating the total cost of the current state. States will be changed in accordance to the simulated annealing algorithm, and after a defined number of iterations, we will be reaching to an optimal position compared to the current methodology. For the programming of the algorithm, we used Python language, and for the designing of the graphical user interface, we used Qt, which is compatible with Python. When using the software, the components of the drawing should be marked as follows. The lighting loads should be marked as circles, other loads as squares or rectangles, and switches as circles. Wall boundaries should be marked with circles at the end of each line. In the system, we get the installation layout as an AutoCAD file and an image file. The AutoCAD file should be in the DXF format and is used to extract real locations of the data. The image can be in any format such as PNG or JPEG and is used to communicate with the user through the GUI. For this demonstration, we will be using a simple layout. To insert it to the system, it is changed in accordance to the input requirements mentioned before. The software does not calculate the design currents of the loads and the distribution boards. They should be calculated by the user, and the design current information should be fed to the software at the correct instances. Now let us go through how we can use this software. This is the first interface of the build software tool. When clicking the Choose File button, File Explorer message box will pop up. There you can navigate through the folders and choose the relevant files and click the next button to go to the next window. In this window, first we must define the number of distribution boards and levels. In our example, we have total of 3 distribution boards with 2 levels. After clicking the Populate, we must define the number of distribution boards present for each level. Here, level 1 will represent the main distribution board. Then in level 2, there are 2 distribution boards. To define the connections between the distribution boards, we must click Connect DBs button. Then we must indicate the parent distribution board ID and the desired current flowing through the distribution board in accordance to the demand calculations. Then the inserted data of connections will be displayed. In this project, we assume that the main distribution board position is a constant and user-defined position is the closest to the distribution transformer, so the MDB position coordinates should be indicated. To configure the resolution between the image displayed for the user and the actual AutoCAD drawing, we must press the Configure Resolution button and select 2 known points in the image. Then we must give the actual distance between the 2 points and press the Done button. To get a reference point in the image, we must press the Configure Point button and select a point with known coordinates. Then the coordinates of the reference point should be inserted in the given space and click the Done button. Then a message box will ask for the boundaries of the distribution boards. To define the boundaries, we must click the Select button. Then we must select the starting and ending circular points of all boundary lines for the required distribution board as shown. After defining for one distribution board, click the Register button. After defining the boundaries, click the Next button. In this window, we must define the loads and switches by clicking the Define button. Then, for each distribution board, we must define how many loads and switches are connected in accordance to the layout. The information that was inserted will be shown in a label. To configure the switches, click the Configure Switches button. Then, a message box will appear requesting for the locations of the respective switches. Click the Select button from the message box and select the switch position from the layout. Then, press the Done button. After configuring all the switches, information of the switches will be displayed in a label. To configure the loads, we must click Configure Load button. According to the load number of the message box, information such as design current, connected switch, and the phase of the load should be inserted. By clicking the Select button, we can select the position of the load on the layout and press Done. This should be carried out for all the loads. At the end, all the inserted information will be displayed in a label. Using this software, the user can select the cable material as either copper, aluminium, or any of the two. Insulation also can be chosen from PVC, XLPE, or any of the two. When choosing any of the two options, the most cost-efficient combination will be given. For installation methods, we can use either enclosed-in conduit, clip directly, or cable trays. If the clip directly and cable trays options are selected, we can either use armored or non-armored cables. In this example, we use the options choose any for the cable material and insulation. The installation method is cable trays. Then we must insert the ambient temperature of the site, general operating hours of the installation for a day, and the number of operating days for an year. Then we must give the unit cost of the energy that must be paid. Then click the Calculate button and wait for the results. Then you will get navigated to the results page. Here we can see the cable type selected and the optimum cable layout selected in accordance to the software. The blue lines shows the cable path from the loads to switches, and magenta line shows the rest of the cable paths. The cost breakdown from the conventional method and the output of the software is shown as a result. Then the selected distribution board position and the cable sizes for each cable path is shown. With that, we have come to the end of the demonstration. Thank you.